Hi folks, so welcome back. So this is the video that will go with exercise 2E. And as you can see, 2E talks about the modulus of a whole function and the modulus of just x within that function. So I'm going to be going through examples 17 and 18 and showing you how you can check those on your graphical calculator. So in example 17, you can see it just down here. So our function is x squared minus 3x minus 10. So very simply, we can chuck in x squared minus 3x minus 10. And we'll just check that that's all in range and that's good. It looks terrible. So we'll go V Windows standard. Much better. Move it down a little bit, maybe. There we go. Okay, so we've got the whole, well, not the whole graph, obviously, but the chunks that we need to see. So obviously from there we could find the roots, we could find the y-intercept, and we could find the minimum point using the gsolve function on the previous video that I made for you. And in this one we're also asked to sketch the graph as a modulus of the whole function and modulus just within x. So I'm going to do part B first, so modulus of the whole function. So that's simply shift, catalog, absolute, and then you just do the whole function. So x squared minus 3x minus 10. So with this one, we're expecting anything below the x-axis to be reflected above it. So, oh, I've pressed exit. Whoops, start again. So shift, absolute, bracket. Annoying, there's no copy and paste function. So x squared minus 3x minus 10. It doesn't matter that I've got the other one on there because it will show how it compares to it. So there we go. So let's go back and let's deselect that first one. And then we'll have to move that around. So shift it up. And there we have it. Okay. So obviously now we'd have a maximum point. So we could find that maximum point. So we could gsolve max. There we go. Gsolve root. Doesn't like the root, that's strange. Gsolve y-intercept, that's okay as well. So let's just see why it doesn't like the root. Let's just go V Windows standard, draw, gsolve root. It still doesn't like the root. Okay, interesting. Well, the reason is because we're taking the absolute value. All right, it's a good discussion point actually. Therefore, the absolute value has to have a value. So you can't have a value of nothing. So where it is nothing, it wouldn't really be defined. So you're thinking of the x-axis as not really be included as part of the graph that way. Okay, so that is modulus of the whole function. So going back, if we wanted to do just modulus of x, so this f of modulus of x, so we have to do that everything in turn. So we're going to go absolute, sorry, delete. So we're going to go shift, catalog, absolute value of x squared, take away 3, absolute value of x, take away 10. So let's deselect the first one. Let's just quickly reselect the second one. Let's quickly reselect the first one and think about what we're expecting here. Well, what we're expecting is that anything to the right of the y-axis is going to get reflected, and this bit of the graph is not going to be there. So this bit should disappear, and we should get this sort of shape here that looks like a pair of boobies, possibly. So let's just see if that's the case. So deselect that. Select the third one, and there we have it, as I expected. Okay, so that's that one. So that's just clarified what example 17 has done. So example 17, there we go. There's the modulus of the whole function, and there we have the others. Okay, now this one should be okay with the roots. So gsolve root minus 5 look and 5. So you can't do absolute value has to have a value, 0 isn't a value, okay? So it's okay with that one. We'll probably also do the minimum points for you as well. So gsolve minimum, so there's 1 there, minus 1.5, And there's another one there at 1.5, as you'd expect, yeah, because the value of minus 1.5, the absolute value of that is the same as the absolute value of positive 1.5. So that's example 17. Example 18 I'm going to do as well, and I thought this was interesting because it involves filling around with the range a little bit. Sorry, I'm so snotty. And making sure that we're in the right mode for V window, etc. Okay, so the first thing it wants us to plot is sine of x. So sine of x. So let's make sure that looks good first of all. So it doesn't because we're not in the right mode. So we're going to go V window trig. Now we are in degrees, that's good. So we haven't got to go back to 2 degrees, and we want it between minus 360 and positive 360. So does this look like this one? Yes, it does. Okay. Modulus of the whole thing. So shift catalog absolute bracket sine x, close bracket, execute. So that should reflect anything below the x-axis above it, which it has. Yeah, looks like this one. Final one, sine of the absolute value of x. So we're going to go sine, probably open a bracket here, shift catalog absolute. You might not need to put a bracket here actually, because it might just do, if it's just x on its own, it might be okay. So let's have a look and see if that likes it. Deselect the first one, draw it. How does that look? Absolutely perfect. Okay. Remember what that's done is reflected anything over this side over to here. So it's not that you can't do it without the calculator, but the calculator is a lovely little safety net to check that you're happy with everything that you've been doing. Okay, so that helps you with hopefully the 2 examples that precede exercise 2E. Now we're also going to go through, pop this out of the way a second, we're also finally going to go through the 2 examples that go with exercise 2G, and these are on page 48 to 50, and they go before the final exercise of this particular chapter. So, the first one of those, got to the right place now, so this is the last bit that's all about solving modulus problems. So on this first one, so we are asked to sketch the graph, state the range, so we would have discussed the range by this point, and then solve the equation t of x, which is this one, equal to half x plus 3. So, first of all, so I'm going to go back and I'm going to delete all this stuff. So don't need that anymore. Assuming I haven't messed up and don't have to re-record this video. Nearly there, folks. Thanks for bearing with me. Okay, so what have we got? So we've got 3, and then we've got the absolute value. So 3 absolute x minus 1. So effectively, wherever you get this line, you click absolute, you put the function in, you close the bracket behind it. And then we're going to take away 2. Draw it, no good because we're in trig mode. So V window standard, exit, draw, it looks good. Okay, so they've done it in stages. Ultimately, this is hopefully the same thing. So let's just check that we've got the same y-intercept and the same minimum. So G solve minimum, that's at 1 minus 2. G solve root, the root isn't there actually, but it is at a third here. And then G solve y-intercept, that's at 0, 1. Fantastic. So the range of this, so the range will simply be, so the minimum point is at 1 minus 2, so it's bigger than or equal to minus 2. And then for the final bit of this particular example, it wants us to then solve this function that we've inputted here equal to a half x plus 3. So I'm going to pop in as well, half x plus 3, draw the 2 together. You can see there's 2 intersection points for this one. So that looks good. In the book, they have got those as 16/5 and minus 4/7. So intersection, minus 4/7. Yes, I know that's minus 4/7. I've done this a lot. And then 3.2, yeah, that's 16/5. Brilliant. So that's so incredibly powerful. Final example is example 23, where we're asked to state the range of f, give a reason why f minus 1 does not exist, and solve the inequality f of x is greater than 5. So again, first we need to do is input it properly. So 6 minus 2 absolute x plus 3. So we've got the range there, the possible y values. So that looks pretty good. So we need to find the coordinate of this maximum point, and then we need to find what's below it. Okay, so the maximum point has coordinates minus 3, 6. So the range is going to be, so y is going to be less than or equal to 6. I'm going to mute myself for 2 seconds, guys, while some students are leaving the room next door. Okay, sorry about that delay, folks. It was very loud outside for a second. I didn't want that to affect the video. So yeah, I've just done part A of this. The reason f minus 1 does not exist is because you can only have an inverse of a 1-to-1 function. And this function that we have here is a many-to-1 function because we've got more than one value of x going to the same value as y. For example, 0 and minus 6 both go to 0. In terms of then solving the next bit, so f of x greater than 5. So I'm just going to pop in 5. So where this is greater than 5 is going to be either side of these two values. So G solve intersect, so minus 3.5 and minus 2.5. So between those two values, this graph is bigger than 5. So in terms of the notation, it looks like this. Okay, folks, hopefully that's been useful. As I say, a really, really easy thing to check on your calculators. Really doesn't take very long, and in an exam situation you would then know that you've got it right and you don't have to come back to those questions. Thanks very much. See you soon.